Let's move on now to an analysis of the pricing and production rules under perfect competition. And let's start with this question. Given a market structure of perfect competition, what kind of conduct with respect to pricing can we expect? That conduct is captured in this equation. Price equals marginal revenue equals marginal cost. Our task now is to prove this. Of course, showing that price equals marginal revenue is a piece of cake. In fact, we already did it in our earlier discussion in which we observed that the profit-maximizing, perfectly competitive firm is a price taker in the marketplace. Therefore, the firm faces a horizontal or perfectly elastic demand curve, so the firm's marginal revenue must be equal to price. Having said that, let's go to the harder task, which is to show that profits are maximized when the firm sets marginal revenue to marginal cost. This, in fact, is the profit-maximizing rule, MR equals MC. Let's demonstrate it first with the help of a table and then with a graph. Here's the table. Going through each of the columns and reminding yourself of the definition of each is a good review of the last lecture. Now see if you can fill in the empty boxes in the columns for marginal revenue, marginal cost, and total profit, where total profit is simply total revenue minus total cost. Does your table look like this? So looking at this table and applying our MR equals MC rule, at what price and quantity will profits be maximized? To answer this question, notice the relationship between marginal cost and the price of $35 at an output level of 8, where price also equals marginal revenue. Increasing output from 7 to 8 has a marginal cost of $30, which is less than $35, so it makes sense to do so. However, increasing output from 8 to 9 has a marginal cost of $40, which is more than $35, so it does not make sense to do so. Therefore, 8 units is the profit-maximizing output, just as our MR equals MC rule indicated it would be. As we shall see, this MR equals MC rule is an accurate guide to profit maximization for all firms, not just perfectly competitive ones. In fact, the other portion of the equation, P equals MC, is simply a special case of the MR equals MC profit-maximizing rule for perfect competition. Now here's a very interesting conclusion from our table. If the profit-maximizing firm always sets its output at a level where marginal cost equals marginal revenue, then it must be true that a firm's marginal cost curve must also be its supply curve. This is how this situation looks graphically, using the data from our previous table. Now, how might you calculate the firm's profit simply by looking at the graph? Here's some options. Did you get it right? Profits are measured by A, B, C, D. One way to think about this is that total revenue is simply price times quantity, or the rectangle ADGF. Total cost, then, is simply the average total cost, or ATC, times the quantity sold. This yields the rectangle BCGF. Subtracting it from ADGF gives us the green profit box ABCD. Voila! Now, suppose that instead of looking like this, the firm's ATC is actually a lot higher and looks like this. This could happen, for example, if it had to pay higher wages or more for its raw materials. How much profit would the firm make now? Did you get it right? The firm suffers a loss of A, B, E, D. Now here's a harder question. Given the firm's loss, should it close its doors and go out of business? If not, why not? The perhaps surprising answer is that, at least in the short run, the firm should remain in business, even in the face of negative profits. The reason has to do with what's called by varying names as the shutdown rule, the shutdown condition, or the close-down case. The shutdown point comes where revenues just cover variable costs or where losses are equal to fixed costs. When the price falls below the level where revenues are equal to variable costs, the firm will minimize its losses by shutting down. To further understand this rule, remember that a firm must still cover its contractual commitments even when it produces nothing. That means in the short run, the firm must still pay fixed costs such as rent, interest on bank loans, and salaries to key management personnel. To illustrate the shutdown rule, suppose the firm in our example has fixed costs of $40, but the rectangle of loss only equals $20. Clearly, it is better off to continue to operate in the short run because losses are minimized. Put another way, what would you rather lose, $40 or $20? Now here's a really tough question. In light of the shutdown rule, how must we change our definition of the firm's supply curve as it relates to marginal cost? The firm's marginal cost curve is still its supply curve, but this is true only for that portion of the marginal cost curve that lies above the AVC. If you got this, go to the head of the class. In fact, there are lots of industries that go through cycles of large short-run losses without shutting down. Knowing what you know about the shutdown rule, which type of industry is more likely to incur such losses? An industry with low fixed costs, like coffee shops and dry cleaners, or a capital-intensive industry with high fixed costs, like automobiles and the airlines? It's the capital-intensive industry, of course. The higher the firm's fixed costs, the more it has to lose by shutting down.